Good afternoon again. I'd like to thank Kaya Kirk and Oliver Vadno for their talks so far this afternoon, and I hope they gave a good understanding of where Cybernetica is coming from in these topics and how we not only offer technologies, but services and a vast array of research opportunities for those problems that we don't yet fully understand. What I would like to speak with you now about is the digital identity technologies specifically, and those that we should be focusing on. There are different services available online. More and more are being made available every day. And therefore, there are different methods of confirming that those customers and citizens that are engaging with us over the internet are who they claim to be. But what I want to focus on specifically is high assurance services, those services that have a significant amount of value or have the potential for a lot of consequence if the wrong person is acting as someone else. And over the past few decades, there have been a range of categories of technologies that we have been focusing on. Starting from the left here, we have hardware token-based options. These are things like smart cards, SIM cards, USB keys that have been around for up to 30 years. They're still around today, and for good reason. There is no question these are some of the most secure technologies on the market. They are dedicated security hardware. What they enable is not only security, but genuine customer possession, physical ownership, just like other identity credentials that we might use, like passports, driver's license, or identity cards. These documents have security features that have a significant amount of technology and research put into them to ensure that when I present it to a customer, to a service provider, they can be confident that this is a real document issued by a trusted provider. Similarly, it is very difficult for someone else to replicate that document with my details. And this goes back to Kaya's points about how the two things we want to achieve here is the ability for our customers and citizens to prove they are who they claim to be, but also to prevent anyone else from claiming that they are someone else. So hardware tokens have been around for a long time, but as we start to move through the years, we find that they're not as convenient as people need them to be anymore. Smart cards, USB keys, and even SIM cards aren't usable on tablets or laptops. They often require additional hardware like smart card readers, or simply aren't compatible with the connections on other smart devices. So we move to a newer generation where we start to focus on things that can work with smartphones, what's in our pockets all the time. And so in the recent years, cloud signing has become more popular. What this embodies is centralized hardware security modules, or HSMs, where rather than storing private keys that we use to authenticate ourselves or digitally sign, rather than keeping those on chips, dedicated security hardware in the pocket of the end user, we keep the signing key in a dedicated security hardware centrally away from the end user. This solves part of the problem. It solves the problem of protecting the end user's signing key. We have to remember, though, that the end user also needs to confirm they are who they say they are via authentication. And this is usually presented with another authentication key. But in the case of cloud signing, we have to address this in a different way with a different technology and one that isn't as secure. So though cloud signing starts to solve the problem of key protection and enabling end users to use smartphones, there are some downsides. We lose that possession-based piece that the hardware token-based solutions provided us. The end users can possess no cryptographic material related to their signing key. And so this next generation that we are pioneering in the area is using threshold cryptography and multi-party computation. And what this allows is we get the best of both worlds with private keys that are generated in multiple shares, where we get the possession, the physical ownership and control that hardware token-based solutions have always given us. But we also get the ability to use smartphones by utilizing the hardware security modules that cloud signing has put forward. And so moving forward, we're really only looking to these last two generations of technology, and ideally the latest generation that achieves the best of both worlds. Because you can see here from these two graphs, there has been a steady increase in terms of mobile banking usage around customers around the world, and an increase, faster moving increase in simply population penetration of smartphones. So The challenge that we're always trying to manage here is convenience versus security. I've mentioned already that smart cards and USB tokens rarely work on phones and tablets and laptops, and so they start to lose the race when it comes to convenience. But there is no question these are some of the most secure solutions on the market. They offer trusted, certified protection of keys. When we look to smartphones, these are not devices specifically designed to protect private keys. In fact, no solution storing an entire private key on a smart device has ever achieved common criteria as EAL 4 plus or EIDAS high here in Europe. And this means that we can't fully trust smartphones to fill the security piece that we need them to. But of course, where we lack security, we start to gain inconvenience. And smartphones are more than just convenient for the end user who simply needs their smart device to act online, but they are convenient for the digital identity service providers. Rather than hardware tokens requiring in-person engagement to update them or replace them, smartphone-based applications can benefit from remote updating. And of course, as phones start to advance, and they do become the kinds of devices that are designed specifically to protect secrets, this is when we can start to utilize that remotely and take advantage of the new technologies phones are presenting, the new technologies that we find from security research, and we can always stay at the forefront of secure, high assurance, and convenient solutions. Also, when we talk about software-based solutions, we achieve fast deployment and cost-effective deployment. We have future-proof solutions that don't need to be manufactured and shipped out, but can simply be downloaded onto the end user's phone, and they can verify their identity and begin. So what we have here is this cyclical challenge where we want to have as little to no change as possible in the way people live today by utilizing their smartphones, which of course makes smartphones the preferred device over hardware token-based options, which are seen as inconvenient. But like I've said, they are dedicated security hardware and they're designed to protect secrets. And so this is what makes them better than smartphones, which unfortunately today we still see as a hostile environment that we must or we can't trust. So of course, I want to introduce you to Cybernetica's answer to this challenge, split key. How split key achieves this balance between convenience and security is that the private keys of the end user, both for authentication and signing, are generated as multiple shares. So what this means is that the host, the digital identity service provider, need only protect a share of each key. And this takes a lot of the liability away from the host, where cloud signing solutions leave the liability on the host to protect the entire private key for all of their customers. In the event of a breach, a leak, or maybe an insider attack, which are more common than we might think, everything is there for an attacker to act. But as with split key, the shares of the keys are separated. What is on the host's backend is of no use in the event of a leak. Secondly, because split keys are stored separately, some of which are on the end user's device, it puts genuine ownership and control in the hands of the end user. It is impossible for anyone to act on behalf of that end user unless they are physically possessing that device with a PIN code that the end user stores in their head and nowhere else. And this is something that we find more and more that our citizens, our customers, our end users are expecting that they are the ones in control. Technically, they don't have to put their trust in the service provider who claims that they will, of course, protect their keys and let them use them when they need to. The end user wants to be the one in control and in possession, and this is what split key achieves. Finally, rather than only protecting a signing key, as we see with cloud signing, split key protects both keys in exactly the same way for authentication and signing. And so we don't see ourselves with a weak link that provides access to a better protected key. How this all works in summary is that the private keys for end users never exist in the whole. They are never in a single place that could be stolen. They are generated in two shares, one on the client device, whether it is a smartphone or tablet, in fact, any iOS or Android device, and the other shares are stored on the hardware security module of the host. There are a few key points that I'd like to draw out related to this technology. First, the private keys, the full private keys that never exist, are 6K bit, but in fact, These, though they don't exist, they're composed of two 3K bit shares, each one providing industry standard security levels. These keys are generated and stored by independent entities, like I've explained, which means the protection of these keys never relies on a single device. And this is what we would call security by design. We look to rely as little as possible on the end user's device, whether they have the latest Galaxy S21 or the 6-7-year-old Galaxy S6. They will receive the same level of security. As long as their operating system is functioning correctly, their keys will be protected in the same way. There are additional levels of security that are provided. For example, a transaction-generated code, which is presented to the end user on their device, as well as their web browser or the application that they're using. This means that if they are being phished or there is a man-in-the-middle attack, presentation of a false website will be shown by either a mismatch in codes or simply the inability to present a code at all. I mentioned about trust in the solution, and Kaya described how trust is a key foundational principle of digital identity. And with split key, because there is genuine ownership of the keys with the end user and there is shares of those keys at the host, signature creation, it has to be an interactive process. And so for the end user, nothing can take place without their input, meaning they can trust the service won't be able to act without them. And similarly, because some of their keys are stored online, any sort of offline tampering or activity will be of no use. And so the service can trust that every interaction that takes place is as trusted as it can be because everyone must be involved. I mentioned how we rely as little as possible on the end user's smart device. And how we manage to achieve this is that no reference data is stored on their phone. In the event their phone is stolen, in the event that their private key share is stolen from the device, because there isn't any reference data, there is not enough information for any attacker to actually act. And so offline brute forcing is impossible. Again, another layer of security that's added on top of this security by design is that PIN verification takes place online and indirectly. And so when it takes place online, it means that multiple incorrect PIN attempts will be recognized and the keys can be time locked or permanently locked if necessary. And when I say that the PIN code is verified indirectly, what this means is that the PIN code is never presented to the host. So this leaves trust for the end user to know that the PIN code they have, it's not stored on their device, it's not stored at the host, and it is never shared with anyone. So I've explained a lot about the background of split key in the technical sense and how we see it as one of the most secure, high assurance credential technology on the market. But it's not just us that's claiming this. Split key has gone through several years of evaluation prior to being used by banking, the banking sector here in the Baltics, the governments for the most high value services that they offer. There's a list of organizations that have taken part in this evaluation. Some of the banks, Nordic banks here in Estonia, were the first to use a service called Smart ID, which utilizes split key at its foundation. The banks carried out their own penetration testing prior to using the solution. Similarly, governments in the region who are also using the technology carried out their own evaluation and penetration testing before trusting it and offering it to their citizens as a way to access the most valuable government services. Split key itself went through almost 2 years of evaluation at TÜV IT in Germany, an international auditing body that carried out the certification for the common criteria EAL 4+ certification. Part of the reason it took so long was simply because this technology had not been presented to them before. And so it's something new for them to see and a lot for them to learn. And finally, we had international auditors carry out compliance audits against PSD2, like Kaya mentioned, the second European Payment Services Directive, which is required for all banks in the EU for transaction verification, and for eIDAS High, which is the EU's regulation for digital identity at the highest level. To achieve such certification and be the only smartphone-based solution that has achieved these levels of certification required years of research and development by a team of genuinely world-leading experts in their fields. You'll remember that Oliver Vadno spoke about our research and development department, which has a specific research institute with many people working on the areas of information security as well as cryptography. And with split key, there were 5 PhDs that provided input to the cryptographic concept that powers the technology. Split key was designed specifically to facilitate common criteria, and the reason for this was so that it could be the prime technology choice for governments, financial institutions, and any other organizations that require these high levels of assurance. Often, in order to offer such remote services to citizens, these are the certificates that are required to actually achieve this. And so we had teams of system architects, cryptographers, security engineers, and usability experts to not just create a secure solution, but one that has a great user experience and is great for everyone that is using it. And so I've talked a lot about security and assurance and how the technology achieves that. But we are always thinking convenience versus security. And so when it comes to convenience, simplicity is key. And you'll see here that it is as simple as it gets. This is actually my bank that I'm looking to log into here on the left. Once I submit my username or my ID code, my phone presents me with a PIN pad. Simply inputting my 4-digit PIN will decrypt my share of the private key in order for it to create a signature. And that signature can be sent to the host, where it's combined to confirm I am who I say I am and give me access. But all I see is that PIN pad. It takes just 3 or 4 seconds. Similarly, rather than authentication, I'm looking to sign something. Maybe I want to verify a large payment transaction. Maybe I want to sign an employment contract or a business contract, or maybe a government application for driving or heavy vehicles. Again, once the details are in, I click submit or sign, and I'm presented with a PIN pad asking for 5 digits. And I input those digits and I have it paid. Again, just 3 or 4 seconds. Registration is also very straightforward. Cybernetica offers end-to-end solutions, and so the registration flow can be customized to fit the host services and how they want their customers to go through the process. But on a high level and a quite standard level, simply the end users must download the split key application, which can be customized to the service provider. And in downloading it, they can start the process and they will be presented with a code. That code can be presented in person along with a government issued identity document to the registration authority, where they can confirm the identity and provide this information to the certificate authority with an automated process that issues the certificate to tie the foundational identity, like Kaya had been describing, with the private keys that will be generated in the background. Similarly, rather than in-person enrollment, just as easy is remote enrollment, where we can utilize partners, like we've mentioned, to present the end user with the option of using a trusted digital identity or an identity document, maybe like a passport or an ID card. And if it has NFC, this can be utilized to draw information off that card and compare that to the end user's face, or it can draw information from a government biometric database to carry out the same activity. Either way, once their identity is verified, the code can be presented and a certificate can be issued, tying their foundational identity to their new private keys, creating their digital identity that can be trusted by everyone. Once their identity has been verified and a certificate is issued, it's simply a case for them to choose their PIN 1 and PIN 2 for authentication and signing, confirm their identity details on their own device, and then confirm PIN 1 and PIN 2 again. And in that final confirmation, they sign the entire transaction. All of this takes just 2 or 3 minutes. And again, like I mentioned, can be customized and designed to fit existing registration processes that may be in place in a government, like for passport issuance or driver's license issuance. Or if these aren't in place, we can help to design and develop the necessary procedures. I showed you what authentication looks like and signing looks like from the user's point of view. But to go a little bit deeper and show you what this looks like in the background, on the left here, we can start with a set of example authentication or digital services offered online. Here we have a telco, government website, a couple of banks, and a education portal. If I were to input my ID code or my username into any of these sites, they will send a request to the digital identity service provider asking for an identity confirmation. The digital identity service provider will send me a push notification to my device with a message asking me to sign it. And that way, it's presenting me with that PIN pad we've already seen. Upon inputting my PIN code, I decrypt my share of the key to create a signature which is sent to the digital identity host. The host will then combine the signatures created by the other key shares that it's storing. And once that signature is completed, it can confirm that yes, indeed, the person trying to log into your service is indeed who they claim to be. Therefore, I can confirm that identity. And again, all of this happens in just 3 or 4 seconds from the user's side. I'll note that authentication happens in exactly the same way as signing. And this is important to understand that we get the same level of assurance for identity claiming as well as digital signatures. There are a wide range of use cases. Many I'm sure you can think of yourselves. For example, here in Estonia, the service that uses split key offers authentication for banking, citizen portals, healthcare portals, education utilities, and a wide range of others, because it is a fast and convenient two-factor authentication solution that takes just 3 to 4 seconds and has those two factors that are most important. First, possession. A physical possession factor, I believe, is genuinely the key factor that should be in any digital identity solution. And secondly, the PIN code that is not stored anywhere. Unlike passwords, where we're looking for a comparison of the password you present and a password stored on file, the PIN code is not stored anywhere and therefore is a secret only the end user knows. The PIN codes are different again to passwords in that the PIN code used to protect the private key on the end user's device is cryptographically tied to that key. And that's how we can verify it without presenting it. I've mentioned already that much of the responsibility of the end user's device to protect the key is removed, no matter the age, make, or model. As long as it's an iOS or Android device with quite reasonably old base level operating systems, we can utilize them. Similarly, there are a wide range of signing use cases. And so split key is the right technology for services that need that high level of assurance, EAL4+, to create legally binding qualified signatures equal to handwritten signatures. So the split key service that Smart ID used here in Estonia, Latvia, and Lithuania can provide legally binding signatures for all of the EU. And here they are recognized as equal to the smart card and the SIM card based offerings, the hardware token based offerings that are used locally. As I've mentioned, there's the evaluation and certification that has led it to be this trusted. And we already have almost 3 million users across the EU using this solution for signing medical prescriptions, making large financial transactions, trading, license applications for driving, for maybe a medical license, changing identity details when someone gets married, and of course, contract signing. The best case study we can provide is the service I've mentioned a few times, Smart ID. It's an authentication and signing solution that's offered by an Estonian qualified trust service provider here in the Baltics, in Estonia, Latvia, Lithuania. It's been in production for almost 4 years now and has approximately 3 million active users. Though 3 million may seem like a small number compared to the populations in the ASEAN region, that is actually more than 50% of the adult population in this region. And this small group make up to 75 million transactions per month across 150 services in both the public and private sector. This is an example of an extremely mature solution where each user on average is using it almost 25 times a month. Of course, its EID is high recognized by the Estonian government, so we can get qualified signatures equal to those offered by the smart card and SIM card. And all of this is only possible because split key is at the core and has achieved these levels of assurance that can ensure that we can have a smartphone-based solution that is equal to the hardware-based options. Finally, as Kaya and Oliver have described, Cybernetica offers a wide range of services, not only technologies. And so we offer end-to-end digital identity service, integration and implementation, starting from consultations to understand what is in place in your region or in your organization, to understand how best we can integrate our technology into a service that benefits both the company, the country, and the end users. We can offer proof of concepts based on our back-end hardware so that fast and effective evaluation
proofs of concept can be set up. We can engage with local trust service providers, and if in the case that there isn't, we can actually set up trust service providers and PKI to ensure that the foundation is laid for national digital identity solutions. We can design both the business processes, the technology and architecture to ensure that it fits your particular needs. If we think about SplitKey, it is just a piece of the puzzle that enables the overall service to achieve the highest levels of security and assurance, but the service itself requires so much more. And this is what Cybernetica can provide through design and collaboration with local trusted partners. We can also customize any aspect of the service by developing custom applications, custom portals, and even custom registries and digital signature platforms. Finally, of course, we want to be able to provide you with the service that you need and step away so that you can run it. So after testing, we provide training for all of your people to ensure that they are confident they can operate a production solution even when the worst might happen. Finally, we'll be there to support deployment. And if there are any components within that separately that are required, we can offer them individually. So I hope that that has given a good understanding of what we offer, what we should be looking for in digital identity. Because as we offer more and more services online, we see more and more companies rising to offer solutions like one-time passwords via SMS, looking to offer things like Google Authenticator. And these are clever and more effective authentication solutions than passwords. They don't reach the same levels necessary for digital signatures, which can lead to the reduction in processes, in resources, in physical offices. And this is where we're focused. So finally, I will pass you on to my colleague and the newest member of the Digital Identity Department team, Adrian in Singapore, who will introduce you to himself and also how he can work with you locally to solve your digital identity challenges. Thank you very much.